Good morning, fourth grade. We are going to start out with the word problems from 9.6. Like I said on Friday, I wanted to go over these, and then I'll go over your lesson 9.7, which is the last one in your chapter. Number 14 says, Dean selects teakwood stones and buckskin stones to pave a path in front of his house. How many meters long will each set of one teakwood stone and one buck stone be? Well, a teakwood stone is 3/10 and a buck stone is 41/100. And we know that in order to add 3/10 and 41/100, we have to turn the 3/10 into hundreds. So we have to multiply the top by 10 and the bottom by 10. And it gives us 31/100 plus 41/100, which equals 71/100. Number 15 says, the backyard patio at Nana's house is made from a repeating pattern of one rose stone and one rainbow stone. How many meters long is each pair of stones? Well, a rainbow stone is 6/10 and a rose stone is 8/100. So we have to turn 6/10 into 100. So we have to times the top and the bottom by 10 and get 60/100 plus the 8/100, that's the rose stone, and we get 68/100. Number 16 says, for a stone path, Emily likes the look of a rustic stone, then a rainbow stone, and then another rustic stone. Explain how long will the 3 stones in a row be? Well, a rainbow or a rustic stone is 15/100 and a rainbow stone is 6/10 and then another rustic stone. But before we add the 3, we have to take the rainbow stone that's 6/10 and turn it into hundredths. And we do that by timesing the top by 10 and the bottom by 10. And it comes out to 60/100. So then you add 15/100, 60/100, and 15/100, and you come up with 90/100. Number 17 says, which 2 stones can you place end to end to get a length of 0.38 meters? Well, first you need to figure out that 0.38 meters is going to look like 38/100. So we have to figure out which 2 would equal 38/100. And it's teakwood, that's 3/10, and rosewood, that's 8/100. So we turn the teakwood, that's 3/10, into 30/100 and add it to the 8/100, and we get 38/100, and that in decimal form is 0.38. Number 18 says, which is the sum of 6/10 and 2/100? Remember, to make 6/10 a 100th, you have to times the top and the bottom each by 10. And in doing so, you get 60/100 plus 2/100, and you come up with B, 62/100. Okay. And today's lesson, 9.7, it says, how can you compare decimals? The city park covers 0.64 square miles. About 0.81 or 18/100 of the park is covered by water, and about 0.2 or 2/10 of the park is covered by paved walkways. Is more of the park covered by water or paved ways? Well, one way is to compare using models. With our 0.18, that's the ones in the tenths place, the 8s in the 100th place, so we would say 18/100. We've got a square broken up into hundreds, and we're going to color 18 of them. And with 0.20, that's called 2/10, and we have that same size block broken up into tenths, and we're going to color 2/10 of them. And as you can see by looking at the amounts shaded, 0.18 is smaller than 0.2. So our sign's going to look like 0.18 is less than 0.2. Or you could use a number line. If you locate on the number line 0.2 or 2/10, it's right here. If you locate 1 or 0.18, it's back here. So 0.18 is closer to 0, so 0.18 is less than 0.2. Then it says compare equal size parts. 0.18 is 18/100ths and 0.2 is 2/10, which is equivalent to 20/100ths. So 18/100ths is less than 20/100ths, so more of the park is covered by paved walkways. Now, the number line is a very good explanation of how close they are, but 0.2 is larger. On the back, it says place value. You can compare numbers written as decimals by using place value. Compare decimals. Comparing decimals is like comparing whole numbers. Always compare the digits in the greatest place value position first. So Tim has $0.5 and Sienna has $0.05. Who has more money? Well, if we do the models, this is the 10th place, so we have one box cut up into tenths, and we have colored in 5/10. And then our next model is cut into hundredths because Sienna, this is the 10th spot and this is the 100th spot. She has 5/100ths of a dollar. And if we color in 5 of the hundredths, it's easy to see that Tim has more money. If we do it by place values, neither one has any in the ones place. Neither one has one whole. But Tim has a 5 spot in the tenths, and Sienna has a 0 spot in the tenths. And she has a 5 spot in the hundredths. So 5/10 is greater than 0/10, so 0.5 is greater than 0.05. Compare the size of 1/10 to the size of 1/100th. How could this help you compare the size of 0.5, which is 5/10, and 0.05, which is 5/100ths? So how does comparing 1/10 to 1/100th help you compare 5/10 to 5/100ths? Well, 1/10 of a whole is larger than 1/100th of a whole, as we saw up here. So 5/10 of a whole are larger than 5/100ths of a whole. I think the actual drawn out coloring explanation really helps us see that 5/10 is much larger than 5/100ths. It says compare 1.3 and 0.6. Well, 1.3 has one whole colored and a 3 in the 10 spot, so 3 colored in the tens model. And 0.6 has no holes or no ones colored and 6 in the 10th spot. So 1.3 is greater than 0.1. 1.3 is greater than 6/10. Compare 0.39 and 0.42 and write greater than or less than. Okay, when we color in 0.39 or 39/100ths and compare it to 42/100ths, obviously we've got 3 rows of 10 colored, and here we have 4 rows of 10 colored. So 0.39 is less than 0.42. Then it says compare using place value. Both 0.2 0.26 and 0.23 have no ones, so we put a 0 there, and they have both a 2 in the tens place, but a 6 and a 3, so we have to compare the numbers in the hundredth place. 0.26 is greater than 0.23. On the next one, we have the same thing. 0 in the ones place, a 7 in the tens place, and a 5 in the tens place. So 0.7 or 7/10 is larger than 0.5 or 54 hundredths. In a number 4, each of the numbers has a 1 in the ones place and then a 1 in the tens place, but in their hundredths place, there's a 5 and a 3. So 1.15 hundredths is bigger than 1.13 hundredths. And a number 5, it has 4.5 compared to 2.89. In the ones place, there's a 4 here, and in the ones place, there's a 2 here. So this is pretty easy to see that 4.5 is larger than 2.89. I'll let you do the on your own, all by yourself, and tomorrow we'll go over the last unlock the problem on the back. After you finish doing this, the on your own, and unlock the problem, please do your last lesson 9.7 in your chapter. And tomorrow, I'll go over this problem and help you look at your chapter review chapter test. Thank you.